Emostel.
Hello, this is Emmanuel Kadri, and you are welcome to this video on logarithms. This happens to be the third part of our video in this logarithm series. All right, in this video, we are just going to solve a couple of a little bit just more tricky questions on logarithms, but it's not difficult in any way whatsoever. You know, it's just like to expose you to some things, to some stunts that you might need to just throw whenever you are given a question on logarithm, depending on the kind of question that you are given. So, all right, so not so complex, but just follow me up. Good. So in this question, the first one says log 9x raised to power 2 to base 3. Like I told you, this is not tough at all. But if the question says expand this, all right, and simplify the logarithm provided that log x to base 3 is equal to 5. All right, so let's say the question says expand this stuff here. Then after you are done expanding it, it said simplify the logarithm provided that log x to base 3 is equal to 5. All right, so this is just an addition to the question. I just added this to it because I know we'll get to a stage we will arrive somewhere here. All right, but just in case you are given that question that wants you to just do something extra so you don't get stuck. All right, so let's just play with this. Okay, so the first thing we do here is to just expand it. So we have log 9x squared to base 3. We can as well change this 9 to 3. So we have log 3 raised to power 2, then x squared, all to base 3. Now, according to the law of logarithm, we could put up the power together since it's the same power. Okay, the law of indices, rather, you know, it makes us to understand that we could combine these two stuff, the two products, and then their power, and then make them to have a common power. So, which means generally in indices, if you have something like a raised to power m multiplied by b raised to power m, all right, you are free to say ab raised to power a common m. So that is exactly what we are going to do here. So we make it to become log base 3. So we have 3x all together raised to power 2, which means this power 2 is working for both 3 and x. So otherwise, without the brackets, it will look as if I'm writing 3, then x raised to power 2. But with the bracket, it means the power 2 works for both 3 and x. Okay? So having this, we can now take this to the other side, making it to be like 2, like this, 2 log 3, then 3x. All right? So we are still on point. Then we now say 2, open the brackets. What we are going to do here is that we are going to apply the law of logarithm, that product rule. Product rule which says log a b or log xy is equal to log a plus log b. So we are going to apply that because since 3 is multiplying x, so we can change it to become log 3 to base 3 plus log x to base 3. Okay? All right. So we now have 2 multiplied by, log 3 to base 3 is 1, then plus log x to base 3. All right. You get that? But the question, this is just You can leave the answer this way. If the question just wants you to expand it, okay, you can leave the answer either this way, or you leave the answer like you expand brackets. 2 times 1 is 2, plus 2 times log 3x, log x to base 3. We have 2 log x to base 3. This is a form of the answer, all right? This is one form of the answer, which is perfect. You can leave it this way or you leave it this way, no problem, it's fine. Okay, depending on what you find in the option, if the question only asks you to simplify. But in the case whereby the question wants you to still do something further, like I said, given that log x to base 3 is equal to 5, all you just need to do is to slot it in, all right? So, since log x to base 3 is equal to 5, you can just slot it in and say, therefore, we have 2 plus 2, all right? So log x to base 3 is 5, just put the 5 there. And then you have 2 plus 2 times 5 is 10. And then the final answer is 12. So, which means that the logarithm of 9x squared to base 3 is equal to 12, provided that the logarithm of x to base 3 is equal to 5. And so, that's just that as per that. Okay? All right, so that's the end of this first question. Check. We move to the next. If you want to check something out, you can pause the video and then check out, make your notes, then we move. On to the next one. For the next question, we have log x, the cube root of y, everything divided by z squared. It looks scary, right? But it is not. It's quite very, very simple, very simple. So what the question wants you to do here is just to simplify it, just to break it down. That's what the question wants. No special stuff. Just change the form from this form to another form, simplify it, break it down. So let's go. What you do here, you might just want to change this thing to another form. Okay, make it look like log this x multiplied by y raised to power 1 over 3. You know, according to the law of indices says that a raised to power x over y is the same thing as what? Y roots a raised to power x, according to the law of indices. So which means that we having the cube root of y is the same thing as, so therefore cube root of y, like we are reversing it, cube root of y is the same thing as cube root of y raised to power 1, because any number raised to power 1 is that number. Okay, so we now reverse it to become y raised to power, according to the law of indices, the one inside will be up, the one outside will be under. Okay, so we have 1 here, 1 will be up, and then 3 outside will be under. Okay, just like the law of indices. Okay, so which means that the number outside the root will form the denominator of the fractional power, while the number that is a direct power to the number will be the numerator. So the numerator is a power, while the denominator is a root. Okay, the denominator, but collectively both of them are power, or we can call it a fractional power. Okay, so that's just a brief revision of indices. Okay, so so that is what gave us what we have here. So we converted the cube root of y, we converted it to y raised to power 1 over 3. Then everything now divided by z squared. Okay, but all to the logarithm to base 10. Invisible number here means to base 10, right? Good. So at the end of the day, we can now apply the law of logarithm. That is the quotient rule. Applying the quotient rule which says that log x over y, okay, is equal to log x minus log y. So that rule is what we apply here. So we are now going to have, this one is now going to become log x y raised by 1 over 3, okay, minus log z raised by 2. All right. Now, here we apply the product rule. In this place, we apply the product rule. So applying the product rule means that, you know what the product rule says? When they are multiplying, you use plus. But when they are dividing, you use minus. So here, since they are multiplying, x is multiplying y raised by 1 over 3. So we are going to use plus to simplify this part. So this part will now give us log x plus log y raised by 1 over 3, okay? Then, that is for these two parts. Then you now put this one here, minus log z squared, okay? Minus log z. Some people call it z, okay? Log z squared. Yeah, this is Africa, Nigeria, z. So, all right, so now we move on. Then this, you now further simplify it by writing log x plus 1/3. According to the power law, the power will go and multiply the logarithm, 1/3 log y, all right? Then minus 2 log z, all right? You can stop here, which is perfect. But you may still want to change the answer and give it another look. If you want to give it a different look, you can say log x plus, 1/3 log y. 1/3 log y is the same thing as log y times 1, which is log y divided by 3. 1/3 log y is the same thing as log y divided by 3. So 1/3 log y here, you can say log y divided by 3, then minus 2 log z. This one is also good. It's also good. And if you think you are still not satisfied, you can also leave the answer in, you can find the LCM, okay? The LCM of everything is, you can take this one to look like over 1 divided by 1. The LCM of 1, 3, and 1 is 3. The 1 times 3 is 3. 3 times log x will give us 3 log x. 3 log x. Then this plus, you bring it down. 3 and 3 is 1. 1 times log y is log y. Okay, this minus, you bring it down. 1 and 3 is 3. 3 times 2 log z is 6 log z. All right, so this is just simple fractional. If you don't really know how I got about this, the LCM thing, then watch our video on fractions, okay? So now at the end of the day, we got all of this. So the answer can be presented this way, or this way, or this way, all depending on the option that is given in the question. Because it might be an objective question where you'll be given the question and be given different options for the answer. So just check out which option goes well with your answer. That is what will determine where you stop. You may choose to stop here if you find an option that goes with it, or you choose to stop here, or you choose to stop here. However the case may be, keep doing the right thing and you keep getting right. Keep doing the right thing and you keep getting it right. All right, so good. We move on to the next one, question number 8, quickly. Okay, the 8th question says 2 log x base 2 plus 3 log y to base 2 minus log z to base 2. Okay, so the question just wants us to break it down, to simplify it, no problem. So what we do is, you just reverse the power law, okay? You make it to become log x raised to power 2 to base 2 plus log y raised to power 3. This one goes here, this goes here, log y raised to power 3, then to base 2 minus log z to base 2. All right, it's quite simple as that. Now, because all of them have the common base, you can apply the rule, both the combination of the product rule and the quotient rule, to simplify it further by bringing everything to logarithm to base 2. But this one and this one will multiply to give us x squared multiplied by y cubed. Then since this is subtracting, so it changes to division, that is divided by what? Divided by z. So we can make it look like log x squared. This is x squared, all right? Since they are adding, so you make it multiply y cubed, all right? Then subtraction means division, okay? Then you put it there. Everything to a common logarithm to base 2. And by so doing, we are done with this, because actually there is nothing more to be done. Okay, you got it? All right, let's quickly check out for the next question. Question 8. Question 9 in a jiffy. The question says solve for x. All right, I wonder why I kept it as intermediate, because it is not. It is it's supposed to be one of the basic. Okay, so this logarithm of 3 of x to base 5 is equal to 3. Solve for x. Very simple. All right, to solve this, what you do is to apply that rule, the basic logarithm rule, which says that the base will carry this result here as the power, and then this one goes. So we just reverse indices by saying 5 raised to power 3, 5 raised to power 3 is equal to x. The logarithm disappears. 5 raised to power 3 is equal to x, the logarithm disappears. But if you do not even want to do it that way, okay, let me put this as method 1. Method 1, 5 raised to power 3 then as x, right? Good, so you have it as 5 raised to power 3 is equal to, since you have x here and then you want to solve for x, you don't know what x is, you can apply the law of indices in an attempt to make the two of them to be the same. All right, so the question is, you can reverse, you cannot make the two of them the same. Please pardon me, but you can reverse it. Okay, you can make it to like x is equal to 5 raised to power 3, and since x is equal to 5 raised to power 3, we have 5 times 5, 25, then multiply by another 5. That should be 125, I think. So that's 25 times 5. Yeah, 5 times 5, 5. 5 times 2, 10. Yeah, that's 125. So you have 125. So that is the answer for that. But if you do not even want to solve it this way, you can use a different method. Method 2. Method 2 is that you may choose to, since this is the question, we have log x 5 is equal to what? 3, right? No problem. So you could choose to make it like to make it the same logarithm on both sides. So you can say you can convert it to log x to base 5 is equal to 3 log 5 to base 5. Okay, you create log 5 to base 5. Since you know that log 5 to base 5 is equal to 1, so it looks like 3 times 1, which is 3. Okay, so you just make it log 5 to base 5, right? So after doing that, you now say log x to base 5 is equal to, you take this one here to make it log 5 raised to power 3 to base what? To base 5. So now, since you can cancel log base 5 both sides, it is allowed. Okay, since you have the same logarithm on both sides, okay, you are free to cancel them out. So when you cancel them out, you now have x is equal to 5 raised power 3. And if x is equal to 5 raised power 3, it means x is equal to what? 125. You can also solve it that way. You can just experiment. You can perform different stunts. You will still keep getting the same results in as much as you're doing the right thing. Okay? All right, so there are still many things. You may just apply any applicable logarithm rule or anything that is mathematically permissive to solve it, and you will still get the same answer in as much as you are doing what is right. So don't forget, keep doing the right thing and you always get it right. So that ends number 9. So let's quickly solve for number 10. You can pause the video and check it out. Okay, for question 10, For question 10, you have log x to base 2, log x minus 2 to base 2 equals 3. Okay, now to solve this question, what you do is that you may choose to apply the multiplication rule here. Okay, you apply the multiplication rule, and that's the product rule, to bring this together and then make this one. Or yes, you will still end up doing that anyway, or you log both sides first. Okay, you convert this 3 to something like 3 log 2. Okay, that is also permitted, just like the way we did in the previous question. So let's do it quickly. So we have this log. You can bring it together into 1. Okay, to base 2. You have x multiplied by x minus 2 is equal to 3. All right. So if you have it this way, you can have all of this, multiply it, knowing fully well that since this one is plus, that's the reason why we use multiplication. All right. Since it is plus, that's why we use multiplication. This x here, and then this x minus 2 here. Okay. So I have to separate it with brackets to just show that there are 2 different entities multiplying each other. Then in that case, you have it this way. Log to base 2. Okay, x times x gives us x squared. Then x times minus 2 gives you minus 2x. So you expand the brackets in that way, then it's equal to 3. Now the question is, how do we get rid of this 3? Quite simple, right? What to do to get rid of this 3 is to introduce a logarithm to base 2, so that I can be able to cancel it out, just the same way we did in the previous question. So you have log 2 x squared minus 2x is equal to 3 log 2 to base 2. You get that? Just for us to have log 2 logarithm to base 2 on both sides. So you can repeat this and then have x squared minus 2x, then it's equal to log raised to power 3. Okay, this 3 goes here to form a power. All right, so you have log x squared minus 2x to base 2 is equal to logarithm of 2 raised to power 3 is 8, then to base 2. Okay, now we have logarithm to base 2, they can cancel out. Since all of these things are inside a bracket, okay, it's not as if they are separate. If they were separate, you may not be able to get rid of it. But since it is just like logarithm of this one is equal to logarithm of this, it's only in that kind of case that you can cancel out. But if you have something else standing out, or something like that, that is not carrying that logarithm and is separated by plus or minus, you may not be able to apply that rule. So we are applying the cancellation rule or whatever, because it just looks like you said log p is equal to log p to base 10 is equal to log q to base 10. And since you said the two of them are equal, you can cancel out this thing and say p is equal to q. All right? So it's just like this p is everything here together, and then this q is everything here. But if you add it like log p, okay, plus q is equal to base 10 to base 10 log r. If you have something like this, because this one is not having logarithm, you cannot apply the rule. You cannot just cancel out. Then if you cancel out, what happens to this plus q? But if everything was carrying logarithm, you can have, okay, log 10p plus log 10q equals to log 10r, no problem. You cannot still cancel yet. Before you cancel, you make sure that you bring this one into a single logarithm. As single logarithm to base 10, p times q, then equals to what? Log to base 10r. Under this condition, you can now cancel out. You must just be having a single logarithm on this left and a single logarithm on the right. And whatever logarithm that you have on either side must be governing a group or a single entity. If that is not the case, you cannot cancel out. You understand that? If you are still confused about what I just explained, you can reach out to me. Okay? All right, then we have this and we have this. So this cancels out because it is just logarithm governing the whole of this thing. So everything here is seen as a single entity because they are under an umbrella of a bracket. Okay, all of them, submitted to log 2. Okay, so this, and then you now have x squared minus 2x is equal to 8. Now the next agenda is, how do we solve this? This is more looking like a quadratic equation. To make it more of a quadratic equation, you can say x minus 2x, then you bring this 8 to this side, that is minus 8 is equal to 0. So now we have a quadratic equation. So the next thing is to solve it quadratically. Now, to solve the quadratic equation, the next thing you do is to look for, since there is no coefficient here, the rule of quadratic equation is that whatever is here, multiply it with anything that is here. Anything here multiplies anything here. So we have 1 times minus 8, we give you minus 8. Now that you have minus 8, look for two numbers that will multiply to give you minus 8. But when they add or subtract, it will give you minus 2. We are looking for two numbers that will multiply to give us minus 8. But when they add or subtract, okay, it is going to give us minus 2. So what are those two numbers? Well, the two numbers is 2 and 4. 2 times 4 will give you 8, right? Then how can we make 2 and 4 to give us minus 2? You make this one positive, this one negative. All right, so if I'm having 2 and I'm owing 4, then I'm still owing what? 2. So if you multiply these guys, it will give you minus 8 because plus times minus is minus, 2 times 4 is 8. But if you add, okay, it's going to give you minus 2, which is here. Now that we have been able to achieve those two values, instead of writing all of this, we'd rather repeat it as what? X squared. Instead of writing minus 2x, we'd rather write plus 2x minus 4x, because plus 2x minus 4x will still give us minus 2x. Then we have minus 8. Now we have left the topic logarithm. We are inside quadratic equation. Okay, so equate everything to 0. Okay, now having all of this, you now factorize by grouping. Factorize by grouping means, okay, let me just move on to the other side. Okay. So when you factorize by grouping, you are going to take this as the first group and take this as the second group. In the first group, what is common? The common factor is x. X can go here, x can go here. In terms of letter, in terms of number, nothing can go except 1. So let's focus on the letter x here. You open the bracket, then you divide this. X squared divided by this x outside will give us what? X squared means x times x. So to take one x and keep one x, you write the result here. Then plus 2x divided by this x. You are going to use this common factor to divide each of them and write the answer inside the bracket. If you don't understand this, please check our video on factorization so you'll be able to understand what it is. Then we have this cancels this, then that is plus 2. All right, we are done with this first part. This minus, you repeat it. Okay? Then in the second bracket, what is common? 4 is common. So you write 4 can go here, 4 can go here. X can go here, but X cannot go here. So you just focus on what can go in both. Now 4, this minus 4 that you have here, use it to divide what you have here. So which means we have minus 4x divided by minus 4. Minus cancels minus, gives us plus, then 4. So we have positive x, okay? Now, we go to the next part. The next part is minus 8. Minus 8 divided by minus 4, this minus 4 outside here. Minus divided by minus is plus, then s divided by 4 is 2. So, now, these two, the content of the two brackets must be the same. If it is not the same, it means you have made mistakes somewhere. All right, so now that they are the same, just keep the content of one bracket, x plus 2, and then take this one and take this one, put the two of them inside a single bracket, x minus 4. All right, so, because if you expand this bracket, you are going to get this thing back, the whole of this thing back. So, all right, let's go. It's just like taking this x alone to multiply x minus 4, and taking these 2 alone to multiply x minus 4. So you know x times x will give us x squared. Then x times minus 4 will give us minus 4x. 2 times x will give us 2x. And then the same 2 times minus 4 will give us minus 8. You see that? So when you expand this bracket, you get this thing back, which means we are still on the track. All right. So whenever you have something like this, what you just simply do, pick one of the two in one bracket, then take this one like this and take the second one like this. Put them in another bracket and you are good to go. Because if you expand this thing, you are getting this thing back. Okay, so now everything is equals to 0. All right? So we now have everything equal to 0. So which means if x plus 2 multiplied by x minus 4 is equal to 0, then two things are involved. Is either x plus 2 is equal to 0 or x minus 4 is equal to 0. Either x plus 2 is equal to 0 or x minus 4 is equal to 0. Because if you say a times b give us 0, if a times b equals to 0, it means either a is equal to 0 or b equal to 0. One of them is equal to 0. That is why when they multiply each other, then the result was 0. Okay, so the same way, if x plus 2 multiplied by x minus 4 is equal to 0, it's either x plus 2 is equal to 0 or x minus 4 is equal to 0. All right, so having that, then we now have x is equal to, you take this 2 to the other side, minus 2, or x, you take this 4 to the other side, x is equal to positive 4. Because when negative 4 goes to the other side, it becomes positive 4. So the answer is, that is the answer for this question. It's either x is minus 2 or x is 4. When you slot it into this, you are going to get the same, you are going to get 3. So let us give it a try. Let's give it a try. So if we insert x as minus 2, so we are having the logarithm of, in this case now, we would rather choose the positive result. So let x be 4. You understand? So if x is 4, we have log 2 to 4, right? Okay, plus log 2, 4 minus 2. Let's assume we don't know that it is equal to 3. So this one will become log 2 raised power 2, plus log 2 base 2, 4 minus 2 is 2. All right, so this 2 goes to the back as 2 log 2, right? Plus another log 2 to the base 2. Now this one becomes 2 times log 2 to base 2 is equal to 1 plus Log 2 to base 2, 1. 2 times 1 is 2, plus 1, 3. So the answer is 3. So we are correct. All right, so it's been a very wonderful journey so far. We got to this place. But then that reminds me of something which I have not touched. Since we did a question that led to quadratic equation, we could as well play with one more question that will lead to simultaneous equation. How about that? So we could still, there are some questions in logarithm that leads to simultaneous equation. So let's just quickly touch that also. All right. Okay. All right, let's do this. We have, let's say we have log x plus log y is equal to 3, log x minus log y equals 1. So this one can be equation 1, equation 2. So having these two, what do we do? How do we go about this? We do simultaneous equation, okay? Simultaneous equation using the elimination method. If you don't know how to solve simultaneous equation 2, please check our video on simultaneous equation as well. So it will help you to understand whatever is it I'm doing here. So my main aim is to, I may not even have to multiply anything by anything since I already have, since the coefficients, this is plus and this is minus, I may just choose to eliminate this, all right? Since the coefficient is already equal, they have the same coefficient, and then this is positive and negative, so we are just good to go. So what we do is to subtract equation 2 from equation 1, okay? So if you subtract equation 2 from equation 1, it means we'll be having log x plus log y equals 3, right? Then minus everything here, log x minus log, sorry, we are not subtracting, we are adding. If we subtract, it will, when there are different signs, you add, but when they are the same sign, you subtract, okay? That is, so that the minus sign will change this sign to the opposite sign to cancel out. So that's what you do. But in this case, we are just adding. We are just adding. We are just adding. And plus does not change anything. So plus times plus is plus, plus times minus is minus, plus times plus is plus. So it doesn't change anything. If it was minus, it should have changed everything here. So adding the two equations, what do we have? Log x plus log x will give us 2 log x. But log y minus log y is 0. So that will be equal to 3 plus 1, which is 4. So now having it this way, 2 log x is equal to 4. All right? What can we do? We can apply many methods to solve it. One of the methods is to say log x raised to power 2 is equal to 4, right? We can say log x raised to power 2 is equal to 4 log. We want to do logarithm of the same base, all right? So, but I don't think applying logarithm of the same base here works. So just leave it as this, leave it this way, okay? Leave it this way, and then just apply the law of logarithm that says whatever base here, we carry this one as a power. So you can just have it as x raised to power 2 is equal to 10 raised to power 4. Knowing fully well that writing ordinary logarithm simply means it is to base 10. If you did not write the logarithm there, okay, sorry, if it is not base 10, the logarithm would have been written. But since the logarithm was not written, you assume that it is to base 10, and then that 10 will carry this power of 4. So if it carries the power of 4, in that case, it means x raised to power 2 is equal to 10 raised to power 4. So, well, yeah, at this point, you can just do some mathematical stunts, like, I want to get rid of this guy so that I can find the value of x. So mathematics allows me to do some things like, it allows you that whatever you do to one side, you do to the other side. Okay? Now, to remove this 2, I can simply divide it by 2. So, which means I can power both sides by half. I can power both sides by half. So, which means I can make it like x raised to power 2, then raised to power half, is equal to 10 raised to power 4, then raised to power half. I can power both sides by half. Now, when I power both sides by half, according to law of indices, the powers will multiply each other. So 2 cancel 2, right? So we have 1. So at the end of the day, it becomes x is equal to what? 10 raised to power 2. Because this one too is as if we are saying 4 times half. The powers will multiply. So 2 here 1, 2 here 2. 2 times 1 is 2. This is like over 1. Okay? So that's the same thing. Then we have, it makes us to have 10 raised to power 2. So which means x is actually equal to 100. Now I have gotten the value of x. I've gotten the value of x. So I want to find the value of y. So insert x equals to 100 into any equation you like, any equation. So let's say equation 1. So equation 1 now, we have equation 1 says log x plus log y is equal to 3. So we now have, since x is 100, so you have log 100 plus log y equals 3. All right? So in that case, log 100 is actually 2. You know why? Because 10 raised to power 2, you know. So we can have it as log 10 raised to power 2 plus log y is equal to 3. Then we make it like 2 log 10 plus log y equals 3, right? So what is 2 log 10? Since we are done with all of this, I think we can just take them off. Okay, so 2 log 10, you know, it's like log 10 to base 10. So that will give us ordinary 2. So we have 2 times 1, that's everything here, is equal to 1. Okay, 2 times 1, then plus log y equals 3. 2 times 1 is 2. So 2 plus log y equals 3. It means log y is equal to 3 minus 2. Taking this 2 to the other side, log y is equal to 3 minus 2. So if log y equals 3 minus 2, it means log y is equal to 1. All right? So I can easily say log y equals 1 multiplied by what? Log 10. Because log 10 is 1. Right? I can say log y is equal to log 10 to base 10, which is 1. Okay? So if I say y equals to log 10 to base 10, since we have the same logarithm on both sides, we can now cancel them out and say y equals 10. So which means x equals 100 and y equals 10. Or you can say x comma y is equal to 100 comma 10. All right? So that is how it goes. If you insert 10 and 100 into this place, you get the answer. So I leave that to you for you to test. So you can just take that as a practice test. Insert this 10 and 100 into this place and then see whether you are going to get 3 by the time you finish resolving it, which happens to be like the first question we solved in this series of the intermediate. So, all right, so that is that as per that. And then don't forget to like this video if you enjoyed it, and then share it with as many people as you can, and join Emostel Academy by going to emostelacademy.org and click on the join button. select your category, whether you are a YX student, JAM students, and all of that. And then we will see you on the other side when you join our academy. Okay? So, but for now, I would like to say goodbye. So the next video is going to be talking about natural logarithms. And after that, we call it a wrap on this topic of logarithm. See you there. Bye.